Mhm. The topic of this hangout is going to be patterns and all the various ways that you can use them. Yeah, yeah, manufacturing patterns. All right. Excellent. So yeah, patterns within the manufacturing. Oh, go ahead. Yeah. Um, they should be able to hear you. Hmm. Okay. Let's see if I can fix that. Sorry. So yeah, OBS is telling me that it's projecting audio through. Can everybody hear me? Okay, let's. Okay, any changes that I make, it's going to take another 20 seconds or so. Let's do this.
I guess I should keep talking.
Okay. So I'm speaking now for... Yeah, so if you can hear both me and Al, please put that in chat. If you can hear me only, please put that in chat. If you can hear Al only, please put that in chat. Yeah. Your audio is playing through that, or I can hear that over your... Anything yet? Just me? Okay, well, here we go. Let's hide ourselves here. Nope, that's not what I wanted to hide. I want to hide me. And Al, if you could do me a favor and mute that audio or just play it through your headphones. Cool. Okay, so let's just jump right into the patterns. To find patterns, Toolpath patterns specifically, those will be located in the browser. So if you select some operations and right click, you'll see add to new pattern. What's really happening here is that you are creating a folder, and that folder has options to create a pattern. So even if I just create a new folder, it's a blank folder right now. If I edit this folder, I can turn on the checkbox for add pattern, and you see all the pattern types that we have here. So let's look at the drop down there. We have linear pattern, circular pattern, mirror pattern, duplication pattern, and component pattern. And component pattern is my favorite pattern that we have here. I'll go over some examples of that later. But let's look at a couple of scenarios where linear pattern could be useful. So what I'll do here is I will create a couple of instances of this vise with our first setup. To do that in the modeling workspace, I'm going to go to create rectangular pattern. The object is going to be the subassembly. Select a direction and pull out the arrow to get some instances here. So let's do spacing. Let's add 4. Okay, so let's pretend that we had a machine with 4 devices that were all doing setup 1. Now there's 2 ways to approach this. You can do it with one offset and pattern the toolpath to all these components, but you could also do a WCS offset, which is you program one and project that to multiple work offsets, and we'll cover that in a second here. But let's add a linear pattern. So I'm going to use the same selections that I just did for that design pattern. So I need a direction, so I can select the line, and then I need to put in the spacing between each one. I didn't keep track of what the spacing was in the other pattern, the design pattern, so I need to go back and check that. But I'm going to put in a number that is approximately close enough. Okay, so that's close enough. So if I flip the direction, so it was about 10 inches for each one. So I'm going to do 4 of those. And it looks like it may have just snapped to 10 inches on that design pattern that I did. Forgot to turn on design history. There we go. Just doing that design pattern one more time because I didn't have design history turned on. Okay, so spacing. Distance, we're going to do 10 inches. 4 instances. Perfect. And again, for the linear pattern, we'll do direction, select an edge, put in 10 inches for the spacing, flip direction, and 4 instances. Perfect. And again, this would work if you were really accurate about setting up your vices. This could be kind of an unrealistic way to use a linear pattern. But what I'd like to demonstrate next is the operation ordering. So for each pattern, when you apply a pattern, you have the option to preserve the order. So do component 1, 2, 3, 4 in series. You can order by operation. So if you are facing, roughing, finishing with different tools, you can do all the facing operations, all of the roughing, and then all of the finishing. And the last one is order by tool. And what this does is if you are using one tool for multiple operations, it will do all of those operations before moving on to the next instance in the pattern. So if you, like the last scenario, if you're roughing and finishing with the same tool, it will face all the components, then it will rough and finish component 1, rough and finish component 2, and so on. So let's leave it on preserve order for now. And let's take a look at an NC program. So with a toolpath pattern, you can simulate the folder, and it will simulate the operations in their correct order. Okay, let's make sure that these are all generated in valid toolpaths. All right, and let's do the same thing for setup 2. And I'm going to create an NC program for setup 1. And I'll use the host post for now. Okay, and the operations. So when you look at the operations tab, this will show you the order of operations that are being posted out. Okay, so again, because we did the pattern in the setup, we will be able to view the exact order that's being posted out from that simulation. But say we were doing a pattern that didn't have that preview available immediately. So to demonstrate that, we're going to change this to a WCS pattern. What you'll see is that in a WCS pattern, instead of outputting coordinates that are for each specific component, so in this case, like the facing, this would be maybe x0, this would be x10, x20, x30, etc. But with a WCS pattern, so let's remove the pattern from this guy. So I'm going to edit and uncheck. Okay, so now there's all those operations are still in that folder, but that folder doesn't have a pattern. And now I'm going to edit the setup and go to post process. And this shows me my WCS offset. So let's make that 1 for G54. And then I'll turn on multiple working coordinate system offsets. And this allows me to specify the number of offsets I want to duplicate this to. Also the increment number, so it's going to increment the offset number by 1. So I'll use G54, 55, 56, and so on. And we get those same toolpath ordering options in here. So you can order by operation by tool or preserve the order. But this is where NC programs comes in handy. So if I order by operation, and then I simulate this setup, it's not showing me the pattern. It's only showing me the operations for that one instance. Let's clean this up a bit. So now if I create an NC program for this setup, and I look at the operation list, you can see we have all of these operations, but it also shows us the instance number. And because we selected preserve order, it's doing all of instance 1. Okay, so all of these operations here. Then it moves on to instance 2, 3, and 4, and so on. So let's go back into that pattern and change the ordering. So I'll go to post process, operation order. Let's change this to order by tool. It looks like it was already on order by operation. Looks like I may have found a bug. Yeah, it looks like it. Okay, so with NC Programs, looks like that's not working right now, but I can post it out, and it does work. Okay, so here you can see we have face 1 on G54, face 2 on G55. So it is ordering by operation in that case when you select that. Okay. Yeah, so a regular toolpath pattern, maybe this wasn't the best scenario for a regular toolpath pattern. Maybe the plasma sign is here. But for a regular toolpath pattern, that's good when you're using one offset, but you have many parts that you're capturing within that one offset. So for example, if you wanted to do a 2D contour on this plate, you wouldn't necessarily need to use a WCS pattern for this because you're not going to have, how many are here? 1, 2, 3, 4, 5, 6. Looks like there's 7. So you're not going to have 21 offsets to cut this part. You're just going to use one. So you could use a linear pattern, and you could put in the 2 directions, 3 instances one way, 7 instances the other. So let's go ahead and do that. And then this one's already set up for component patterns, so we'll get back to that in a second. But yeah, so pattern type linear, direction 1 along that edge. You would put in the spacing. Direction 2. You would specify an additional direction, turn that on. And again, I don't know the exact spacing between these, but we don't need to because I can use this to demonstrate component pattern. Yeah. Okay, so instead of trying to figure all the math behind the distance between each one there, and even the number of instances that you have, instead of using a linear pattern, you can use component pattern. And this is super cool. What you do is, if you use the default settings, leave automatic on, you select a source component. So I'll select this one in the bottom left corner, and it finds all of the other instances of that component, regardless of the orientation. Yeah, so let's try and mess around with this a bit. Oh yeah, so Al pointed out one of the questions is that why wouldn't you, what would you do if you had non-equidistant spacing between components? So let's demonstrate that by putting in a couple of instances here. And I'm not worrying too much about where they're placed. Let's rotate this one too. And maybe one more. Okay, so here's 4 just randomly placed components. If I go back into this pattern here and make sure that's generated, the component pattern will find those other instances. In this case, automatically. And also, if you don't want it to automatically find all the instances, you can select the specific instances that you want. So I'll turn off automatic, and then that lets me choose the targets. So I can say, I just want this one in the middle here. And then it would just do that one. You also have the option of keeping the original. So this is kind of interesting. If you have an assembly, and maybe it's a tombstone assembly, which I have an example of that. You can program a part that isn't actually attached to the tombstone, and then you can select the instances on the tombstone that you want to run, and you can uncheck keep original, and it won't try to put all those toolpaths on that one out in space. So for example, if I just wanted to machine these 3 out in space here, but not do the original one, I can uncheck that, and then that toolpath won't be applied. And again, same ordering options in the drop down here. But let's jump over to that tombstone. Okay, and you can see from the operation tree that I've used a lot of patterns in here to do this. So first, let's take a look at what I did for soft jaws here. And let's hide some components. Okay, so when I modeled these soft jaws, or actually when I modeled this whole thing up, I did a circular pattern to get the vise on both sides, and then I did a linear pattern to get those vices on the second instance of the mount there. In fact, we can play through all of this. Right, so I placed a vise, did all of that, and you can see here is where I did the linear pattern. So I prepared everything that I wanted for the first and second setup. So on the front we have the first setup, on the back we have the second setup, and then I did a linear pattern to get another instance there. And in the manufacturer workspace, I effectively did the same thing where I only programmed one of those instances, and then because I had the other components in there, I could instantly transfer those toolpaths over to the other station. Yeah, right. That is true. So, oh, I'm sorry. It's hard not having your audio. So this is a case where, because this is all based off of one offset on the tombstone, you don't have to use multiple work offsets. You can just do a toolpath pattern and it will place the toolpaths in the correct position. And another clever use of patterns that I did here is that I know that the jaws are symmetric. And so I only programmed one jaw. So I have a roughing pass, finishing pass, and some deburring. And then I did a circular pattern to rotate those toolpaths onto the other side, because the jaw is self-centering, and I chose an axis that was on the vise that was convenient. So I had that jaw programmed by doing a circular pattern. I had the whole vise programmed, and then I stuck all of that into a component pattern. So I've nested all of these patterns to create the toolpaths to create the first setup soft jaws for all of these. Yeah, so Al is saying that I should show NC programs to show the optimization of the toolpaths. So what I'll do for that is I'll show the parts programmed, because it's two different setups that have patterns. Okay, so I have the first component all programmed here. I stuck that inside of a component pattern, so I have the first and second instance. And then for the second setup, I have the same thing. I have all of these operations on the back side. That's programmed for one instance. The component pattern will do the second instance. And when I post these out together, sorry, Al, what was that? Oh, I've got to show the parts. That'd be a good idea. Okay, so there's all the parts. And now for that NC program, I'm going to make sure that the first setup and the second setup are included, so all the boxes are checked. And now I can see the order in which all those operations are going to be posted. So if I uncheck reorder to minimize tool changes, what you'll see is that it's doing all of the first component. I think that's up to about here. And then it moves on to the second component. And what you'll see is if I turn on this checkbox, reorder to minimize tool changes, it optimizes the order so that neither setup will have its order violated. So all of setup 1 will be completed in its order, all of setup 2 will be completed in its order, but it zips together the operations so that the least number of tool changes is achieved. It's really good for optimizing programs when you're including multiple setups. Okay, and we can simulate that result. So if I simulate an NC program, it will show me that order, which is something that you can't do if you just try to simulate setup 1 and setup 2 at the same time. it won't show you those optimizations, but in this case it will. Okay. Another thing that patterns does is, this is kind of a non-obvious thing for patterns, but if you select a operation to pattern and you pattern it around an axis that causes the instances to have different tool orientations, then you will get those transformations built into your program. So, for example, let's take a look at, I'm just going to duplicate the setup, and actually I can delete all the operations that are here. Yeah, let's do that. Okay, so let's say that we wanted to use a circular pattern to program these drilled holes, all of these radial drilled holes on this hub here. So I'll do a drilling operation. I will select an appropriate drill. I believe it's this one right here. So first, I need to select it to orientation. And I can select a cylindrical face to be my Z orientation. It will follow the axis. Z is pointing down right now, so I'm going to flip it. And select the hole. Okay, so there's the hole. I want it to go past the bottom, so I'm going to go into the Heights tab and turn on Drill Tip Through Bottom. Okay, so there's my one instance of the drilling operation. And now I'm going to right click and create a new pattern. And in this case, I'm going to create a circular pattern. With a circular pattern, you need to select an axis, so I can select a cylindrical face. And you see by default, I have two instances going around 360 degrees, so that's a full circle. And I just need to add in the number of instances that I need here. So I think it's 16 maybe. Yep, 16 instances. Leave on the checkbox for equal spacing. I want to keep the original. I don't need to reverse the order. And because it's just one operation, the operation order doesn't matter. I would get the same result regardless of which option I choose here. So a reason you might want to use reverse order is, let's say, oh, I don't have something drawn up for this, but I suppose I could make something. But let's say that you wanted to pattern a drilling operation like this, and the drilling operation was going from left to right on a part. And let's say it was a really long part, like it took up the whole X travel of your machine on a mill. You wouldn't want to go from left to right and then go back and maybe tap a ream or something, those holes from left to right again, because you're wasting machine motion. So you could reverse the pattern and you keep the same selections. So you select the first hole on the left and things like that. But now you have a pattern that will go from right to left. In this case, if you duplicated this pattern, you have one pattern that is going around clockwise. In this case, it's actually going counterclockwise. But if for whatever reason, like maybe you had axis limitations for the travel or something like that, if for whatever reason you wanted to go back the other way the second time, you could turn on the reverse checkbox. So that was right there. And now this one is going the other way around. So if we play those back together, goes back the other way. Now, I have another example that I'll need to draw up here, but it's a clever use of a linear pattern and the reverse option, where you have a 3D feature that you need to finish with a 2D contour to get the wear compensation. So let me just draw that up real quick. And let's extrude that up. Let's do 1 inch for that. And I need a fillet here. So let's say that's 1/4 inch. Perfect. Make that a little higher. Okay, so this is something that I've come across before when I was making real parts for my job. But I want to finish this surface, but I need to use a 2D contour so I can use wear compensation so that this face is within tolerance, right? I might have plus or minus on the tool wear. And this is something that you can't necessarily do with a 3D parallel toolpath because the 3D finishing toolpaths don't have cutter comp. So here's what I'm going to do. First, I'll create the setup. And I'm going to create a 1/2 inch ball end mill, or I can just grab one. And I'm going to use 2D contour. So go into samples. Oh, I should turn on the new tool library preview so everyone sees all the new updates. It's been getting some nice stuff. Okay, so there's the tool I want. I want to create a 2D contour on that. And if I just do one pass, right now the bottom of the tool is just going to the edge. Right, so it's going to right there. That's not quite what I want. I want it to go all the way down to the fillet. So I'm going to edit the operation. I'm going to go into heights. And I know that I want to use an expression to do this. I could type in minus 1/4 inch, but I'm going to type in minus tool corner radius. Doesn't have a corner radius, so I'm just going to do tool diameter divided by 2. Okay, so there's my one pass that goes all the way down to the fillet like I want. Okay. And this is where the pattern is useful because I don't actually want to go from top to bottom. I want to go from bottom to top so that I'm climb milling on the material. So what I'll do is I will add a linear pattern along that edge right there. And you can see I already have my second instance. I want the spacing to be whatever I would use for a 3D finishing toolpath. So maybe 10 thousandths if I really wanted a nice finish. And now I'm going to add a number of instances that gives me the correct number of passes. Maybe 60. Maybe that's one too many, one less, but we can adjust that later. But this is where the reverse checkbox comes in handy. So if I click OK right now, what you will see is that the tool starts from the top and works its way down to the bottom. Right? That's not what I want. So I'm going to go into the pattern, turn on the reverse checkbox, and now it will do these instances from bottom to top. So this is exactly the toolpath that I want. Maybe the leads aren't exactly what I want, but they're fine for now. And I can turn on cutter comp. I like to use wear compensation. So now it'll output a G41 for that pass. Or actually, it'll output a G41 for every pass on here, but I'll get the finished contour that I want there. Al, were there any comments or questions in the chat that I should be looking at? Oh, yeah, okay. I remember that question from the last video. Oh, yeah, there was a question about the turning a tool at 45 degrees for a Mori NTX or any B-axis machine. How are we doing on time? 1:35? Yeah, we're doing okay. What else should we show for patterns? Al, do you have any suggestions? I'm sorry, I didn't quite understand what you meant there. Okay. So there's some comments that it didn't fully click why I didn't use a 3D parallel toolpath, and I sort of hacked my way into it. That's because if I make a parallel toolpath Now, this is a perfectly valid use of the parallel toolpath. That makes a perfectly good toolpath. Don't get me wrong. Let's do one way. Okay, so I need to change this to contact point boundary. Okay, so that is 90 degrees from what I want, so I'm going to edit it one more time. Okay, so what's the difference? And actually, I see some funny leads there. But what's the difference between this and this was sort of the question that I'm gathering. A 3D parallel toolpath, I can't use cutter compensation for. Right? I can't get G41 to come out of here. So whatever this face finishes to with my 3D toolpath, that's all I get. Now, if I use a 2D contour, I can turn on cutter comp and I can make sure that this face is coming out. I can control it effectively. All right, so basically these are the same toolpath, but only the 2D contour I can add wear compensation to. Okay, hopefully that answered their question. Okay. Showing the larger assembly here, the tombstone. Is that what you want to know? Oh no, I wasn't able to get that one to. That one wasn't prepared. Cool. I guess there's not really a whole lot of questions about patterns. We can answer that question about the B-axis lathe, I suppose. That one's an easy one to cover. Okay, sounds like there was some confusion about the multi-vice. Okay, so it sounds like there's some confusion about using a toolpath pattern versus a WCS pattern. So let's clean this up a bit so that we can get a clear. Okay, so these are both effectively the same, and I'm actually going to change this to a component pattern. Okay, so setup 1 is using a component pattern within the setup to duplicate the toolpaths. So I have 4 instances here. This setup 2, let's rename this to setup 2. This is just one component, right? I've only programmed one component, and I have duplicated the number of work offsets that this program is output to using the multi-WCS pattern. So let's take a look at the posted results of each one here. So that one's got that. Let's make sure that preserve order is on. Let's do order by operation. Okay. And let's post this and look at the code. Work offset is on. Orientation is not supported. Interesting. Stick to the linear pattern then for now. Oh, I know what it did. It found all the other instances that were flipped over is what it did. Okay, so with a toolpath pattern, it's not patterning the work offset. It's patterning the coordinates of each operation. So you can see we have face 1, we have face 1 for each component really because it's patterning the operation. But I start off with G54, and you can see the first X coordinate it goes to is 4.56 or 4.65. And then the next facing operation is 10 inches offset from that, right? So this one's 14.65. And the next one is 24.65. So it's patterning the coordinate location of each operation. So you can... Yeah, Al was asking me to explain that on work offset, or I'm sorry, fixtures like laying base plates or the fifth axis rock lock system. There's standard spacing between the positions that you place the vices. For systems like that, it might be 96 millimeters spaced apart exactly. So you can get away with using a component pattern like this where the coordinates are patterned. That's real easy to do. So let's take a look at the WCS pattern setup now. So if I go to the post-process tab, I'm starting with work offset 1. I'm patterning the entire program to 4 different work offsets is what that means. And I'm going to use order by operation again. So what we'll see, if I post the program again, it's the same thing. So it's 4 facing operations in order. But the first operation is G54, and you can see we have X4.65, and then the next facing operation is G55. So it's the next work coordinate system, and it uses the same coordinates again, so X4.65. So you can place your vices wherever you need to on the table, and you just have as many work offsets as you have vices, and you put the number of instances in the WCS pattern in the setup, and you get that many instances out. Despite just programming one component, you get that many instances out. And it's not something that we can simulate because we don't know necessarily how those work offsets were placed in the machine. So you could have a work offset that is, like, let's say you have 4 work offsets. The first 2 work offsets could be spaced 3 inches apart. The next 2 could be 4 inches apart. The next 2 could be 1 inch apart. We don't necessarily know that from the CAM system. All we can say is that, yeah, we're going to output operations to each offset. It's up to you to make sure that they're spaced the way that you want them to be. I hope I was able to adequately answer that. Excellent. Are there any other questions about patterns? Okay, so it sounded like there was a question there. What did you want to show me, Al? Or what did you want me to show? Okay, yeah, so let's cover turning the tool at 45 degrees for B-axis machines. So I don't know what the particular tool that was used in this case, so I'm just going to create a generic one. And I'm going to create a neutral tool to do this. Okay, so the first step is to set up the tool so that it is in its orientation when it's offset on the machine. So when you fill out the values in the offset table for the tool on the machine, you want that to match this image here, because we do have orientation degrees in here, but you want to make sure that you're using the right touch-off point. Okay. So I was told that they're asking for a CNMG insert. Yeah, let's do the new tool library. So if you want to use the new tool library that's still in preview, if you go to preview features and search for tool library, you'll get this checkbox for the tool library preview, which I'm personally quite excited about. And now when you click on the tool library, you get this awesome new interface. And the most obvious change is to the cutting data panel here. So now we have multiple feeds and speeds per tool, which is something that's been really well received. But let's make our tool for the hub. So we're doing turning general. And the insert type is going to be CNMG. Now we have the capability to actually type in what the insert code is going to be, and it'll automatically give you what it needs to be. Okay, so CNMG. I'll leave the sizes the way they are. Make it neutral. And this is just so I can demonstrate that to turn a tool to 45 degrees, you have to know why it's being turned to 45 degrees, whether that's for the tool setup, for offsets, or if it's in the operation. But you would select a tool like this. So let's use profile roughing. I'll select that tool that I just made. CNMG. Okay, there it is. And now, in the tool settings on the tool tab, we have orientation. So you can change this to 45 degrees and it will tilt the tool. And as long as your post is set up to handle this transformation, it will do the calculations for you. So now, when you hit OK, invalid contour, unexpected result. Probably because I don't have spun profile. Oh, I do have spun profile. Just didn't like it. Maybe we can try a simpler part. Let's do this one. And I'll take that operation, I'll copy it in, see what we get. There we go. Okay. Okay, so there's your turning roughing toolpath with the tool tilted at 45 degrees. Again, you would have to make sure that it's set up in the way that you need it for your machine and the post is able to handle that and things like that. But otherwise, from a UI standpoint, this is all it takes. Okay, Al, were there any other questions about... Oh, you know, it just happens to be set to WordPad on this computer because that's the default text editing program. What I'm really going to do is use Visual Studio Code. Yeah. I think George is working on a nice little tool for editing G-code. Okay. Well, let's see if there's any other questions that people have while we're still on. And if there's not any other questions, we'll go ahead and wrap it up. Yeah, and I apologize for the goofed up audio. You guys are supposed to be able to hear Alan. He's been talking to me this whole time. But we'll have to figure that out for next time. Okay. Yeah, sounds like there's some questions around joints. You're welcome to reach out to me directly and I'll answer your questions. You can reach out to me on Instagram. I guess I should put my email somewhere where you guys can contact me. Maybe in the description for the YouTube video. Yeah, everybody is first name dot last name at autodesk.com. So if you want to get a hold of me or Al. Okay, Al, are you seeing anything on there? Okay, so there's a question about projecting a toolpath onto a surface. Is that a 3D surface, Al? Okay. So let's find something that would work for a 3D surface. Or I could just draw one. Let's do that. So here's some object, and let's put an arc on top of that. Oh, it just wasn't showing me. Okay. There we go. Okay. So we'll call that our 3D surface. And I want to project something onto that. And we can do that by creating a sketch that floats over the surface. And that sketch can be projected down onto the surface, and that creates a toolpath. So I will create an offset plane. And the way I'm doing this is I'm right-clicking on the origin planes that are available to me. I'm selecting offset plane, and I'm dragging one up above the part. And let's do a spline. Okay, so we have a spline that is floating above the 3D surface. And I will create a setup. And what I'm getting after is I'm going to create a project toolpath. So in the 3D operations, there is a project toolpath. And let's look for a ball end mill. Looks like I have just a few options here. I'm using the new tool library filters, which are really cool. So I want a ball end mill that is less than, let's say, 1/8 of an inch in diameter. Let's see if any exist in here. Cool, we have a 1/16 ball end mill from Harvey. That'll work great. Or actually, I think this is a sample tool, not from Harvey. Anyway, I select this curve, and it's going to project down in Z. So whatever my tool orientation is now, it will project that contour in the negative Z direction. And there it is. And there's lots of settings in the project toolpath operation for adding axial passes, whether you want it to be up milling or down milling. If you're doing multiple passes, you can do all one way or both ways, things like that. But that's the basics of it. You can create all sorts of sketch geometry that gets projected down and effectively make your own 3D projected toolpaths. Yeah, okay. Okay, so it looks like there was a post question, and George, the post guru, we can get him onto one of these webinars and we can go over post questions. So if you guys have post questions, let us know, and we can have a hangout just for posts. Yeah, so I guess I'm not looking at chat right now, but Al tells me that it's the post question is about adding XYZ 0 at the end of the program. I assume machine 0. Could you repeat that to me one more time, Al? Okay. Yeah, well, if you want to edit your post to do that, put in G55X0Y0 at the end of your post. The function onClose inside the post processor controls all the things that happen at the end of the program. And if you look at that portion of the post, you'll see all of the logic that is writing the current location at the end of the program. So right now it's trying to find the center of the part and do all those things. You can comment all of that out, and you can write in your own location. So you could type in, like if you just wanted it to be hard-coded, you comment out all the rest of the stuff and put in the function WriteLine, and then in quotes you write exactly what you want it to be. And that was a really abridged version of an explanation, but yeah, we'll do a live stream on post editing. Okay. Well, if there's no other questions, Time's up. Okay, awesome. Bye, everyone.